All right. On this ACT question, I'm going to show you something about the TI, whether you knew it or not. It's for future reference. Definitely you don't need it for this question. On here, I can go to seconds and matrix, right above the x to the negative 1 key. And I can edit any matrix I want. This one, I'll press A. Edit A. Notice it says 2 by 3. Well, in this case, I want a 2 by 2. Enter. And you end up with a 2 by 2 matrix. Okay. You can do matrix calculations on this calculator. So I'm going to type in for the first cell 2 times negative 3. I've never done it like this before. Yeah, it works. So I can do 3 times 2 for the second. See how it highlights? That makes it pretty nice. And then you can have 5 times negative 3. This will come up in this class. I'm taking the opportunity now to show you a little bit about a matrix. And then you can type in 4 times 2. And like I said, on the TI, just like anything else, you don't have to, on any other graphic calculator, you don't have to save it. It automatically is saved. The neat thing about this is, I quit, went back to the home screen, is that you can go to second and matrix, and you go to math, and I want the determinant of, I can go back to matrix, I can get the name of it, matrix A, and I can press enter, I come up with 42. Okay? If you want to check matrix A, I can go to second matrix, and I want to see what A looks like, and it shows you negative 6, 6, negative 15, and 8, so you can double check your work. But there's a lot of things you can do with a matrix. I just didn't know if you could do matrix calculations on this calculator. All right? Questions about the matrix? The DET stands for the determinant. The big one that you have to know about, second quit, is R, R, E, F, F. That's the big one. That's the main one, letter B. It stands for reduced row echelon form. That's huge, and we'll get to that in this class. But some of you that remember reduced row echelon form, you can play around with that and have some fun with it. But that's like the main one. Okay, that one the determinant. Because it wasn't that long ago, you had to do everything by manually, and it takes a long time to calculate some things in a matrix. All right. So I wanted to show. I picked that question to show you things about the calculator. Yes, I know you don't need it to solve the question, but I wanted to take the opportunity to do that. And next, have we already done this one? They look familiar. If you remember what this means, you should be fine. If you don't remember what it means, you should still be fine, in my opinion. By this, I mean, so I'll give you just, what, a minute to do this one? Minute and a half? And these are back because of the likes and dislikes. Somebody said I liked it when you did the ACT questions. I forgot I hadn't done them for a while because I think we had a test. I think that's why I got away from it. So I thought I'm going to start bringing those back up next week. The person doesn't like my shoes. Thank you. I can take that in stride. You know, I dress for fashion every day. It's okay. To the person that, one person said, I don't like the way you make fun of people. I don't recall doing that in this class because I'm supposed to treat you guys with kid gloves. It's a lot different in calculus. One person says, I don't like the way you make fun of people. The other person says, I do like the way you make fun of people. It was ironic. I don't know if they got the question backwards or it was like almost boom, boom. It's like, okay, that's fine. What do you get for this one? You. 8. H. How'd you get H? Well, See, when you do these questions, you're supposed to do the question first and then check your answers later.
Oh.
Sometimes. Sometimes you can get by with it. This means for what positive x values is undefined. Obviously, if you take an x squared out of the denominator, you're left with 4 minus x. It is undefined when x equals 0, but that's not positive, so it's obviously going to be x equals 4. Okay? Fantastic. All right, so some of the other likes and dislikes. I had 4 people that don't like the pace of the class. I thought, because they said it's too fast, I thought, the word accelerated's in there somewhere. I'm almost positive that's the whole reason. And then 3 people said they liked the pace of the class. So that one was kind of 50-50. A lot of people said they liked the student solutions online. A lot of people like that. So I'll keep those up for this chapter and see how it goes. All right. So that's the ACT PSAE questions for the day. Any questions on the homework? We got through 3-1 on Friday, didn't we?
Yeah. 1 through 13.
Okay. So yeah, we got a ways. Any questions on 1 through 13? Yeah, Jessica? Huh? 13. All right. Well, I got some fun today to do. Elizabeth's going to be very happy. All right. Find all the values of x such that y is positive and all x such that y is negative. Sketch the graph of f. What the heck does that mean? Y is positive, y is negative. Sketch it first? Do things out of order? Are you kidding me? All right. Y equals clear, clear. Parentheses. Which one am I doing? 13? 1 divided by 4. X caret 3. Everybody knows that this is a snake type of function. And it's dropped 2 levels down. And the 1/4, does that change the y's or the x's in front of it? The y, so it's actually making it wider. I'm going to go to zoom 6. And there we go. Now, on this graph, it wants to know where the y's are going to be positive. Obviously, this is the positive region, this is the negative region. A lot different than if you're looking at the number line. If you're looking at the number line, you have to find some value of x right here, and you'd say this is the positive and this is negative. So however you're looking at it, we looked at it both ways. Do you remember how to find this value on the calculator? Anybody remember? You. Do you remember? All right. Second, calculate 0. A 0 is another term for the y-intercept. A number on the left side of where it crosses is 0. I'm looking at the x value, so I'm going to press enter. Now give me a number on the right side. I'm just going to scroll over until I get to, there. That number's safely on the right, 3. And then I'm going to scroll back down and press my guess. So it's 2. I told you didn't need the calculator. You could have set this equal to 0, solved it, and come up with the answer 2 equals 1/4 x cubed equals 8, x equals 2. So either way, you could have come up with it. Now, for the values such as negative, that's nothing more than for f of x. Negative, that's nothing more than negative infinity to 0. Double sets of parentheses because it can't equal 0. And for positive, again, from 0 to infinity. Sometimes you can solve these manually. Sometimes you're going to have to solve them on the calculator. Just depends on the level of question. All right. Ready? Any other questions? Great. Let's jump back into it, do some fun stuff. Let's see. We did the intermediate value theorem, didn't we? Great! What is the intermediate value theorem? One of you 3 in the back. Thank you. You're up. The intermediate value theorem Okay. Okay. Provided what? If C is between A and B, then the function value C is between A and B, or it could be the other way. You don't know which way. Provided what? One very important fact. In fact, if you know the calculus kids, and you've seen, has anybody seen any calculus kids 7th hour? Good. They're going to be squawking like a parrot today. Okay, go ahead. Provided what? Yeah, it has to be a continuous. And continuous. We are working with polynomials because they have great continuity graphs. Remember the ACT question? The 1 over the 4x squared minus x cubed? That doesn't have to follow the intermediate value theorem because it's not continuous. Over some parts it is, and some parts it's not. Okay? So, with that all said, that's the intermediate value theorem. Great. Did we do this one?
Sure. Yep.
Show there's a 0 between the two?
Yep.
Fantastic. Oh, match the equation to the graph. We did that one. And what's the squared mean? Yeah, it means it's going to be tangent to the x-axis. And the first means it's going to be like a linear factor crossing the x-axis. This isn't on here, but what would happen if you had like a, not a 2, but a 3 at the x plus 2? Let's say I want to draw this graph. Ooh, I'll put a 2 there, and I'll put a 1 there. Nice. I want to draw my own graph. What would the graph look like at -2? Yeah, it looked like it had that feature. It wouldn't be a linear crossing of the axis. It'd be more like a snake going through the x-axis. And what about the -1? Right, it'd be like a parabola. And what about at 1? It'd be like that. Exactly. You would see little pieces of these graphs at the x-intercepts. It might not be real noticeable, but they'd still be there. That's when you're reaching the higher echelon form of reading a graph, understanding what little bits of characteristics help. Okay? Moving on. Do we do this one? Yeah. Oh, same thing. So I'm going to have an x squared based on this graph. That's going to be an x squared. And based on this graph, that looks pretty linear. So I'm going to have an x minus 1. Which one is that? Oh, A. Negative?
No.
Negative where? Who said negative? Oh, you're talking about like the... Well, what does the graph of y equals x cubed look like? It goes like this, doesn't it? If I multiply this out, look, I have x cubed minus x squared. So it is looking like that. So we're in good shape. Had it been coming from the other direction, I could see your case about being a negative. So in one case, you look at the factors around here. In another case, if you multiply it out, you see the whole big picture. That's good. So if I give you an equation of this, you can give me the answer back, correct? Isn't that right, Savannah? Excellent. What would this factor be? No, x plus 2 squared. And what would this one be? X. That's absolutely right. I won't give you all those choices. I'll give you a picture. Then you write me the answer. Isn't that great? I love that. Oh, your surprise is coming here in a minute. Try this one on your own. Just tell me, without looking at the 4 choices, what the answer would be. I told you on the ACT, you should work out the problem first, and then check to see if your answers are there. I have no idea what's going on. Well, I find that hard to believe, A. B, I would agree that you might be tired. And C, a little cranky, possibly if you're anything like the first 4 classes I had through here today. And yawning a bit. Are these crossing through like little pieces of lines? Yes, they are. The only other option right now is this. or this? Yep. Huh? What is it? Right. X plus 2, x plus 1, x minus 3. I could ask a follow-up question like, did you do it in the spirit that was given, or did you look in your book? But I'm not going to do that because I know she did it in the spirit in which it was given. It's crossing. And there are no, cubes or squares in it. So each one has an exponent of a 1. Okay? Thank you very much. Nicely done. What time is it? Are we close to the surprise? Ooh, we're like 12 minutes away from the surprise. All right. Find the values of the graph of f of x such that, we just did a homework question like this. See this? This goes back to what you were saying about the negative x cubed. The predominant feature of this graph is going to have a negative, and it's going to have a cube, so it'll look something like this. What's the 9x do? It affects it a little bit. Gives it more than one crossing point, but the general shape is going to look like that. So I'm going to do this one without the assistance of a calculator. If I factor it out, I have x, 9 minus x squared. I can factor it again, can't I? X, 3 minus x, 3 plus x. I love the number line. Now I just have 3 regions to check. Obviously, I can do them quicker on the calculator, but you see a pattern here on checking the regions. We had in the first section or first chapter on inequalities, followed up with quadratics, and now we're doing the same thing with cubics. So if I put in a 10, that's a negative region, right? If I put in a 2, that's all positive. Negative 2, negative, positive, positive, negative, negative 10 bajillion, negative, positive, negative, positive. I want both regions. Y is positive for, this is a domain question. Negative. How is this working with this type of notation? Are you comfortable with it? Getting the idea of it? Good. Very college-esque. We didn't get this in our last book we had. Yeah, it's a term I made up, meaning more like college. 3 to 0, 3 to infinity. Yes, thank you. All right, so y is negative, y is positive. I'm also curious that in 1 week we take the compass test, November 2nd. Yeah. I'm all worried about next Tuesday. That's okay. The seniors next door go down this week. They're like the first batch through. We'll see how they come out. All right. Do we need to do another one? I think we got the idea, don't we? Yeah. If I was going to do this one, I'd do it on the calculator. But, graph it? Were we supposed to graph it?
Yes.
Oh.
You were supposed to.
All right, let's sketch it. Well, if I'm going to sketch a graph, I'm not going to do all these manual calculations. That seems a little redundant. Well, I guess I could sketch a graph this way. Negative 3 a crossing point, 0 a crossing point, and 3 a crossing point. Positive, negative, positive, negative. There. And I got the negative x cubed graph there. Are the y values accurate at the vertices of the graph? Probably not, but it's a sketch. I don't even have any scale on the y-axis, so it's fine. Okay? And you can see that's a vertice and that's a vertice. That's a change of direction on a parabola. It's what's called. We call it also maximums and minimums. That's a minimum. That's a maximum. We're talking about that in calculus today also. We're going to talk about a lot of things in calculus today. That's a maximum, that's a minimum. Relative maximums, relative minimums. This one. Do you want to do another one? This will be our third one. I think we're good. We need to move on. Sketch a graph of a polynomial given the diagram. Oh. Ha 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 ha. Wait a minute. What time are we? one more minute after this one. It's time for Elizabeth's surprise. Ready? Yeah, surprise. We need to sketch the graph. -3, -2, 0, and 2. The positive and negative obviously refer to the signs of f of x, which are the y values. How can you have a positive? It turns to 0 and goes back to being a positive. Yeah, it's tangent right there. So it's tangent. Then at -2 actually crosses and does all right until it gets to an x value of 0, correct? Then it goes up. Then it goes back down. So that'd be an example of the graph. What degree would this polynomial, what's the minimum degree this polynomial would have to be? Because you can say like x to the 10 bajillionth and be right on every single question. But what's the minimum degree this has to be? Like we know a quadratic has one vertex. 4? You say so. How many people say 4? Now, I'm going to ask you the same question after I say 5. How many say 5 with me? Good, thank you. I got a little bit of support in here. This counts as what kind of a root? Double root? Oh, the double root rears its ugly head. This one, a single. The reason I said a minimum value is because, hey, that could be like an x cubed. Well, okay, that's fine, but I said minimum. So we got another single right here. We got another single right here. So 2, 3, 4, 5 wins. Okay? So that would be a fifth order polynomial. All right, time for the surprise. This one, you do not need a partner. Stand up. All you need are 10. Everybody has. I got in trouble one time because I told a girl to do something when shooting free throws, her belly button. She screamed. She didn't have one and ran to the locker room. So I was going to say, you need 10 fingers for this. Does everybody have 10 fingers? Good. All right, put them together like you're making, you know, like a thought hat. Don't put them on top of your head, though, but just like you're doing it. Anybody, nobody ever made thought hats when they were a kid? Oh, you guys. All right. Now, take the middle knuckles and put them together. Okay? You got it? This isn't that difficult. This, you're doing it on your own. Now, I want you to take and split your thumb and put it back together. Excellent. Do the same with the pinkies. Split it, put it back together. Now I'm going to do the index fingers. Split it, put it back together. And now I want you to do the ring finger.
Got it.
Your knuckles came apart. You can't break up knuckles apart. It's really easy to, oh, you are, no, you're cheating. Look at your, yeah, he's like this. I can do it, I can do it. You got to keep the knuckles together. All right. They say, you know, a few people can do it. But the more, you know, looking at it doesn't help. Some people like this. Look at it. All right, so that was good. Start over. All 5 fingers. You can, you know, depending on how hard you tried, you might have to, you know, get ready for the next one. Now I want you to take your ring fingers and put them knuckle to knuckle.
What the heck?
Ring fingers, knuckle to knuckle. Okay? Now I want you to do your thumb, your pinkies. Ooh, some people struggle a little bit. Index finger and the long finger. Okay? No, it wasn't that bad, but some people kind of struggle a little bit on the pinkies like me. All right, ready? Shake it back out again, ready? Now we're going to go with the index finger down, knuckle to knuckle. Go thumb, pinky, ring finger, long finger. You took all 3 apart. Nice. Yeah. To some. I can't. I'm out. I can't do it either. How'd you do? I thought you were like all double jointed. Yeah. That was the big stories last year. You're all double jointed with your fingers.
I broke mine.
That's right.
No, they were talking about how you could like pop things in and out with your fingers. That wasn't you. I was all excited. I thought, I got the brain break. She's going to really like it because she can like show off her like fingers that can do all these funny. That wasn't you? Wait till I see Bowen. All right, have a seat. Nice job.
Don't ever listen to any of
Okay, I won't. Anyway, so that one you did by yourself. Nice. There's some other ones I came up with, but I'm going to try that one today. Nice job. Nice job. You two were like, stood out the most on different fingers. Did anybody get the middle finger and the ring finger to come apart? I haven't found one person do that yet. Miss Wright about went ballistic trying to do it. But anyway, that's... Oh!
Uh-oh.
Ready?
No.
Can we start doing this at the end so we don't have to go back to work? Yeah.
No, see, that's the whole idea. It's supposed to be in the middle. Anyway, if 1, 0 f of x equals this, find the other two zeros. Can somebody give me like a CEO look about this problem, you know, overseeing the whole thing? How would you solve this problem? Not necessarily give me the number, just give me the overview on what you think when you see this problem. What do you think the negative 2 is there for? Oh, plug it into what? To find k. Because right now it's not calculator ready. All right, so if you plug it in to find k, you're going to set it equal, obviously, to 0, aren't you? So you have 0 equals, because this is the point negative 2, 0. So 0 equals negative 8 minus 12 plus 2k plus 12. So k equals 4, right? So k equals 4. Now you have that little tidbit of information. What can you do with it? How do you solve the equation? You could graph it. What else could you do? Let's see, plus 2x plus 12. What else can you do? Oh, no. This is really cool stuff. Yeah! Go ahead. I don't know. What should it be? Oh, 4x, sorry. Thank you. Minus 4x. My fingers are still hurting. Sorry. Negative 4. I remember I've done this multiple times. I'm still trying to get the ring fingers apart. All right. So 1, negative 3, negative 4, and 12. You remember saying division? You always want to start with a 0, end with a 0. Because that's where it equals 0. You can write it as a factor like this, or it's also an x-intercept. All right? So you add coming down, multiply going around. Add going down, multiply coming around. Now, the reason I do this is I would not pick up my calculator for something like this. If it's on the other side of the desk and I'm sitting there, I won't reach for it. I'll just do synthetic division. There comes a point in time when I will reach for it, but on this one, probably not. Negative 5, 10, what is that? 6. Woohoo, it works. Started and ended. Now this becomes x squared minus 5x plus 6, which means I have x minus 6 plus, oh yeah, there you go, x minus 3, x minus 2. So the other two zeros are 3 and 2. Yes, you can graph it out. The problem with graphing it out is synthetic division gives you all the roots, complex and real. Graphing only gives you real roots, not complex. Just an FYI for future reference. All right. Oh. What I do? What? 3 and 2. I'm done. Excellent. We have a crate problem looking at us right in the face. The crates have square ends of x feet. Express the outer volume of the crate as a function of x. Disregard the thickness of the lumber. What is this? Oh, the frame for shipping crate is to be constructed from 24 feet of 2x2 lumber. Well, does this have to do with anything?
I don't know.
Skip it.
We won't do it.
Oh, wait a minute. You only get 24 feet of lumber, right? Yes, you do. What? Was that Schluter? I think it was. All right, so how many pieces of red length are there? 4 pieces of red length. And yeah, so there are 4 Ys. How many X's are there? 1, 2, 3. Oh, yes. 8, right? 8 X's. So 4Y plus 8X has to equal what? How much? Oh, 24. Express the volume of the crate as a function of X. The volume, how do you find the volume of a crate? It says disregard the thickness. Yeah. Length times width times height or something along those lines. Oh, we did one like this. This reminds me of the rectangular fence problem, right? Divided into 3 equal lengths. I thought there was a surprise in this problem. Maybe there is. I don't know. Y equals 2x equals 12. Oh, sorry, y plus 2x equals 12. So that means y equals 12 minus 2x. Oh, I just put it in there. What's 6? Don't they just want the equation? Y plus. Oh, I divided by 4. I see. 6 and 6. Thanks. All right. I think it's the last one, isn't it? Yeah, it's close enough for me. Oh, there's one other word problem. You can figure that one out, dear. Oh, calculus. Oh, yes. dr dt, we just did that. But anyway, yeah, do the rest of these up to how far did we get? 32? 42? Yeah, so go through 43.
43.
Yeah. 15 to 43. Great. Nice job. How about talk to